a minute. There's a small glitch here. I'm on in 2-3 minutes.
Okay. Good evening, Sampath.
Good evening, ma'am.
Beta, you may keep your video turned on.
Yes, ma'am. Yes.
So yeah, in the last class, we started with the properties of matter first, in which I explained that the matter is made up of particles and how do we prove that the matter is made up of particles. So we prove that the matter is made up of particles by taking 100 ml of water and putting a few drops of ink into it, and then we take that particular ink and put it in a new fresh 90 ml of clean water. We will observe that the color of the ink passes on to that 90 ml water. Then again we are going to take 100 ml water, and again we are going to repeat the same, but from the second beaker now we will be transferring 10 ml of the inked water to the clear water. What are we going to observe? That the clear water again turns uh, to the color of the ink, and we will keep on observing it till a few beakers, which clearly indicates that a few drops of ink were made up of so many particles, very tiny particles, which got transferred from one beaker to another, then to another, and to another, and so on. And same activity was done in the using a chemical which is potassium permanganate, which is initially purple in color. I made them see one video also related to the same. And lastly, we also studied that the particles of the matter are very, very, very small in size. Fine. And then we came to the next topic, which was the characteristics of particles of matter. Today, we are going to discuss only the characteristics of particles of matter. So we started with the first one, that particles of matter have spaces between them. So, Sampath, can you tell me by some activity that how can you say that the particles of matter are made up of, have spaces between them?
Ma'am, if we take some water and add salt to it, and after if we leave it, after some time we see that the salt disappears and mixes in the water. This will show that the salt molecules have gone into the spaces between water molecules.
Very good. That's absolutely correct. That whenever we try to mix the salt or sugar in water, after some time, even if we don't stir it, we will observe that the salt and the sugar particles after some time they disappear. Or if we mix it, in that case also we are going to observe that the particles disappear. So why does that happen? Because these particles take the place which was present in the liquid water. Clear, everyone? I hope the first property was clear to everyone with the activity also. Okay. Then the second activity was to show that the particles of matter were continuously moving. How do we see the movement of the particles? By, for example, if I say that we cook some food, then after when the food is being cooked, we are able to smell the food at a certain distance. Why is it so? Because the smell of the food particles, it mixes with the air and tends to travel. Only because the particles move, we are able to smell the food. This is one example. Or another example is, if I put a few drops of ink in the clear water, what do we observe? If we put the drop of ink in the clear water, for example, we are going to put red ink in the blue water, then what are you going to observe? Tell me. What is going to happen if we try to put ink in water?
The water will change its color into red color.
Right? The ink goes inside the water, means the movement of ink from the top occurs till the bottom and till everywhere the entire water color changes, the color changes to red. Right? Clear, everyone? So we will see the
Yeah,
activity and then we. Yes, Harshit? Any
ma'am.
doubt? Yes.
Yeah, ma'am, I can hear you.
I am asking if there is any doubt anyone is having. Jitendra?
No doubt, ma'am.
Okay, so we will see an activity related to this, and later we are going to study the next one. Just a second, children. Okay, now I'm sharing my screen once again, and then we are going to see the activity for the movement of particles of matter.
Now let us learn how the particles are moving. To find, let us do an activity. Activity 1. Take an unlighted incense stick. If you want to smell it, you need to move close to it. Now light it and place in corner of your class. You can find the difference. You can smell the incense even from distance. Activity 2. Take 2 different beakers filled with water. Add a drop of blue or red ink along the sides of the first beaker. Add a drop of honey the second beaker. Leave them undisturbed. Now you can observe the difference between the 2 beakers after adding ink and honey. In the first beaker, which is added with ink, is evenly distributed in less time compared to honey. Activity 3. Take a crystal of copper sulfate or potassium permanganate and put into a glass of hot water. Take another crystal and put into cold water. Do not stir the solution. Let the crystal settle at the bottom. Now can you observe any change in crystal in the glass? Yes, the rate of mixing of crystal into water is differing from one glass to another. Here, the particles of matter are moving continuously, which is called as kinetic energy. As temperature increases, particles move faster, so mixing of crystal is faster in warm water. Mixing of crystals is slow in cold water. Intermixing of 2 different particles of matter on their own is called as diffusion. Don't you think that why mixing is faster in warm water? Because the particles attract with each other. The particles are held together with maximum force. Now let us learn why it happens. Activity 1. Now let us take an iron nail, a piece of chalk and a rubber band.
So the activity which you just saw, in that what happened, the ink particles got mixed with the water, honey particles got mixed with the water. About the term diffusion, now we are going to study. It is a very, very important term which everyone should know. And there are 2 definitions of diffusion, one which you are going to study in your biology class and another in chemistry class, but both will be considered in chemistry and both will make sense also. So what is diffusion? The intermixing of particles. I will explain you the meaning also. The intermixing of, good evening, Akshra.
Good evening.
The intermixing of particles is called diffusion. So what does this term means? That the mixing of 2 or more particles with each other is called diffusion. This is the definition which we study in chemistry. Whereas what you will study in biology, or might be you have already studied, is that the movement of particles, and I'll tell you how both of these make sense also. The movement of particles from a region of higher concentration to a region of lower concentration is called diffusion. So what actually diffusion is? It means that mixing of two particles occur together, right? Two or more particles occur together. And whereas the other definition says that the movement of particles from a region of higher concentration means where the concentration of the particles is high to a region where the concentration of the particles is low. For example, if we consider the example where we say that, where we take this example only, that we take a beaker and then we put a few drops of honey into it. So what will happen? The honey will come at the bottom initially, and if you leave this honey for some time, what are you going to observe? The water is there. So this honey particles will start to move upwards and try to mix upward and downwards wherever the honey is not there, right? So what do we observe? Where the honey was more means when it got settled at the bottom. From the bottom, it starts to move upwards with the other particles of water. So wherever the concentration is high, the movement occurs from there. Since honey is dense, means it is heavier than water, that is why it got settled at the bottom. Whereas if we talk about ink particles, the same water we take, and if we drop some ink particles into it, then what are we going to observe? The ink particles tend to move from up to downwards. Why so? Because the ink particles are light in weight. So since they are light, so from up they were more, they gathered at the top and then they tend to move down. Clear everyone? Fine. Clear the meaning of the diffusion. First,
Yes,
the
ma'am.
mixing of ink and water, or honey and water, or the maybe the movement of the particles of the instant stick mixing with the air. How does the smell of instant particles come to us? It comes only when we are far apart, but the smell of the incense particles tend to mix with the particles of the air, and then it travels along with the air, right? The same thing happens. This you must have observed in your everyday life also. Yes or no? I hope this much is clear to everybody. Now let us come to the third property, which is these properties, children, are all related to each other. Like if you understand one property, it is related to the second, and the second property is related to the third property. So you should know all of them. So the third property says that the particles of matter attract each other. So I'll come up with a very easy and important NCERT question by which you can relate to this activity also, this property also, and you will be able to understand also. Okay, if we take a wooden block of tiles, then what do we do if a kid tries to hit it? Or leave, not this. Okay, I'll take another example. If at all we try to move our hand in the air, we are able to do so. But if we try to do it on a wooden block, will be able to do it? No. Why is it so? Jitendra,
Yes, ma'am.
what do you think? We are able to move our hand in the air freely wherever we want to, but if we have to move our hand in the wooden block, will we be able to move our hand through it?
No, ma'am.
So can you think of a reason why is it so?
Particles in wooden block are tightly packed, ma'am.
Or we may say in another word, that's absolutely correct. But in other words, we can also say that the particles of matter in the wooden block have attracted each other very, very strongly as compared to the particles of the air. That's why we were able to move our hand in the air, but not in the wooden block. Right? Clear, everyone? Yes, Harshit, is it clear to you? Okay. So we will okay, one more before we see the video, I will explain what you are going to see. If we take the iron nail, I hope everyone is aware what does an iron nail mean. And if we take a chalk piece and I try to hammer both of them, which you would be able to break easily?
Choke.
Yes. Why again? The same reason. In the iron nail, the particles have attracted each other very, very strongly as compared to the chalk particles. The particles in the chalk are not attracted as strongly as the particles of the iron. Clear, children? So we will continue with the same video which we were seeing before, and there we will read the NCRT also.
Now let's try to break them by hammering, cutting and stretching. Do you think which
I'll
particles
just
are held
rewind
together
a
with maximum
little.
stretching? And a rubber band. Why it happens? Activity 1. Now let us take an iron nail, a piece of chalk and a rubber band. Now let's try to break them by hammering, cutting and stretching. Do you think which particles are held together with maximum force? Activity
So tell
2.
me which particles are held together by the maximum force in the example which was shown?
Iron nail.
Iron nails. Very good.
Open a water tap and try to break the stream. Can you cut the stream? No, we cannot. But how does the stream remain together? Because the particles of matter have maximum force acting between them. So, the force kept the stream to remain together. The strength of force of attraction is different from one matter to another.
Okay. I hope this was clear to everyone. Yes?
Yes, ma'am.
Yes, ma'am.
Okay, children. So let's move further. Okay. So an important question I would like to ask from you people. So my question says, why we can easily swim in the swimming pool? Just think of the properties I have discussed. Why we can swim easily in the swimming pool? Can anyone answer? Think of these three properties. Can anyone answer? Think of these properties, you will be able to answer. It's not that difficult.
Ma'am, the water particles in swimming pool are not continuously moving.
No, all the particles are always continuously moving.
Ma'am,
Hmm.
ma'am, is it because the particles were there in the swimming pool, the water particles are not that closely packed together like in salts, because of which we can freely move in it?
So basically, we can say that they have spaces between them.
Yeah, we have spaces
The
between.
first property which we studied, right? And one more property we can relate to it. We can swim in the swimming pool, but not on a wooden block. Why so? Because the wooden block particles are not attracting us, but the swimming pool water is letting us be inside it. That's why we are able to do it. So the particles of water attract us. Us means we and the water. There are two particles. The particles have attraction between each other. Clear, everyone? So we will first read till here in NCRT, and then we are going to move further. Fine. I think, as far as I remember, we read the first property already, or we didn't. We did, I think so. We did. We read the first property.
No, ma'am, we didn't. Like,
Okay, so we will start from here. Characteristics of particles of matter. The first one is the particles of matter have space between them. So Jitendra, you start reading this one, page number 2.
In activities 1.1 and 1.2, we saw that particles of sugar, salt, Dettol, or potassium permanganate got evenly distributed in water. Similarly, when we make tea, coffee, or lemonade, particles of one type of matter get into spaces between particles of the other. This shows that there is enough space between particles of matter.
Okay, stop. Harshit, can you read activity 1.5 now? Harshit?
Yeah, ma'am.
Yes, please read.
Drop a crystal of copper sulfate or potassium permanganate in a glass of hot water and another containing cold water. Do not stir the solution. Allow the crystals to settle at the bottom. What do you observe? Just above the solid crystal in the glass. What happens as time passes? What does this suggest about the particles of solid and liquid? Does the rate of mixing change with temperature? Why and how?
Stop now. Okay, children, if we talk about the temperature, we discussed about the lighter and the heavier particles. I explained you about honey and ink, right? But if we talk about the temperature, I'll give you a very easy example which you can relate to very, very easily. If we take a glass full of milk, one we are taking the milk from the refrigerator and other we are boiling the milk, fine. And then we have to add maybe Bonvita to it. So tell me in which you will be able to see the addition of the Bonvita more easily amongst these two.
Ma'am, hot milk.
In the hot milk, even when you try to add sugar, if you keep the sugar as it is in the cold milk, then it takes some time to get the sugar mixed in it. But when you try to heat the milk and then you try to add the sugar, then it becomes easier for us to get the milk, the sugar added. So this very clearly means that apart from the being light and dense, the diffusion depends mainly on two things. First is the density, which I have explained you by taking the example of ink and honey, and another it depends on the temperature. So when the temperature is more, hot means the temperature is more. So when the temperature is more, the diffusion occurs faster. The mixing of any two substances occur faster. So it is directly related, directly proportional. Do you understand the meaning of directly proportional?
Yeah, ma'am.
Yes, ma'am.
No? Yes? Means it is directly related. If you are increasing the temperature, the diffusion will increase. If you are decreasing the temperature, the diffusion is going to decrease. Right? And then if we talk about the density, if the things are denser, then the diffusion is lesser. Means it is inversely proportional. It is inversely related. Clear? Good
Yeah,
evening,
ma'am.
Pranav. You are so late for the class. Pranav, are you there? Okay.
Yes, ma'am.
Anyway, are you able to understand what I'm telling?
Yes, ma'am.
Okay. So basically, there are two factors on which the rate of diffusion depends. Diffusion basically means the mixing of two or more particles with each other. For the ones who have joined just now, I'll just quickly brief of what we have studied. I think one more child is there, so I'll just quickly tell you about the diffusion, then we can read. Okay. So just a second, one more child is joining. I will start speaking. Rohit, you are also so late for the class. You were there in the last class, or is it your first class?
Ma'am, first class.
First class. Okay, no problem. I'll just quickly brief you. We are not going to move further, children. I'll just quickly brief whatever we have studied so that those who have joined, they're able to catch up with what we have studied, fine? And whatever test you're going to have, only this much will be coming in your test, not much more than this. Okay, children. So we have, good evening, Vignesh.
Good evening, ma'am.
So, beta, I'm just briefing what we have studied till now, fine, so that you are able to catch up whatever we have covered till now. Okay, so the first and the foremost thing I had told about is the chapter which we are going to start, which is matter in our surroundings. So, what actually matter is anything that occupies space and has mass, fine. Also, matter is anything which we can feel using our sense organs. Like, for example, air, we cannot see the air, we can just feel the air, right? So, matter can be felt using any of our five sense organs. Then there were ancient philosophers who concluded that matter is made up of 5 main basic constituents. The first one is air, next is fire, then earth, then sky, then water. Fine. They said that the entire universe is made up of these 5 things. Any doubts still here, anyone?
No, ma'am.
Vignesh?
No, ma'am, clear.
Then we took a few examples in which we classified things to be matter or not. This already has been uploaded. You can just look at the PDF which I have uploaded of some things which
Yes,
I
ma'am.
discussed, if they are matter or not. Fine. Then there are 2 theories which came up with various scientists. A few scientists said that the matter is continuous. Like, for example, if we look at a glass, if we say, what do you think when you look at the glass? It looks like it is one continuous thing, like there is no breakage in between. Whereas when some scientists said that no, the matter is not continuous, it is made up of very, very small particles present in it. So, how we made the conclusion that it is continuous or made up of particles? We took the example of glass and we said that if we take a glass, the glass means maybe the spectacle glass or any glass. So if we take that glass, not the not the glass which we drink, the glass which is transparent through which we can see anything, huh? So the glass, if we take it and if we drop it, if we look at it, it appears to be continuous, but when we drop it, it shatters into very small particles, right? So by taking this example, we concluded that matter is not continuous. It may look continuous, but it is not continuous. It is made up of many, many, many particles. Clear, everyone?
Yes, ma'am.
Yeah.
Yes,
So,
ma'am.
yeah. Now, what could be the particles? We said that the matter is made up of particles, but what particles is matter made up of? The particles which make up the matter, they are either atoms or molecules. Now, what are atoms or molecules? Atoms are the smallest particles which make up the matter. Means, like if we talk about a room or maybe a house at your, if you talk about a house, what do we say? House is made up of brick. First, we take one brick, we take another brick, we make one wall. Then by making one wall, we make another wall, then we make another wall, then we make another wall, we make a room. After making so many rooms, we get a house, right? So what was the building block of the house? The brick. Similarly, the building block of the matter is the atom, means the smallest unit which make up the entire matter. When these atoms combine, they form the molecules. I hope this is clear.
Yes, ma'am.
Rohit, is it clear?
Yes, ma'am.
What about
Yes,
the
ma'am.
others? Any doubts?
No, ma'am.
Okay. So, children, now these particles which we are talking about means the atoms in the molecule, they are very, 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 very small in size. Fine. So, then I explained that how can we say that the matter is made up of very tiny particles. So we have made 2 characteristics of matter. The first characteristic is that the matter is made up of particles, and the second characteristic is that the particles of the matter are very, very small in size. This is the characteristic of matter, right? And how do we show it? We show it by you have to imagine what I'm saying. This is very easy. You can easily relate to it. If we take a glass and put 100 ml of water into it, and we add 20 drops of ink in it, blue ink. So the water becomes entirely blue in color. Then I take another glass and take just 90 ml of water into it, and then add 10 ml of the water which was blue colored, the previous one, right? Then what are we going to observe? This 90 ml water will also acquire the blue color. Yes.
Yes, ma'am.
Yes, ma'am.
And then if I repeat the same activity, I take another 90 ml of water, and now I put the water from the second beaker, which was a little lighter in blue color as compared to the first one. So when I did so, Then I observed that the third beaker also acquired blue color, but it was lighter as compared to the first and the second one. Means that those 20 drops of ink were made up of so many particles which kept on getting transferred, and the color started to get lighter because the particles started to divide itself. Whereas there were so many particles that it could color so much amount of water, like 300 or 400 or 500 ml of water. Only 20 drops of ink could color, right? Clear, everyone?
Yes, ma'am.
And children, the same thing we observe. I will be sharing a few links also of these activities which I made everybody else see. You can refer to the YouTube to see those links. So the same activity we do in the class with the purple colored salt in the lab that you are going to do in the school, in your school probably, by using this purple colored salt, which is potassium permanganate. So same thing happens with this salt. This is initially purple in color, and when we keep on transferring these the solution, then the purple color gets lighter to pink color, but it keeps on transferring the color to a lot of water. Fine. Then we came to the main topic, which is those were two characteristics of matter. Means that matter is made up of particles, and the particles of the matter are very small in size. Now these particles which make up the matter, they have their characteristics. So we study three characteristics of particles of matter. Now the first one was that the particles of matter have spaces between them. How do we say that the particles of matter have spaces between them? Very simple, very easy example. If we take a glass of water, we put some ink or maybe honey or maybe salt or maybe sugar into it. Any of these if we put, what are we going to observe? You people tell me. Rohit, what do you think will happen if I put a few drops of ink into a glass of water or honey into a glass of water? What are you going to observe?
Ma'am, the water will change the color a bit.
And also, if we mix like honey, so we can taste the honey, we can
Yes,
also
ma'am.
feel the taste of the honey. So what happened actually was there was space, and ultimately after some time, we are not going to observe the honey in the glass. Why? Because what happens is the whatever the space was present in the water, that was occupied by the particles of honey, right?
Yes, ma'am.
This showed us that the particles of matter have spaces between them. Then we came up to the second property, which was that these particles, they are continuously moving. The same example you can say, if we if we keep a few drops of ink and we drop it into water, what are we going to observe? That the entire water gets colored, right? The same thing you always happens. So this means that the particles of the ink moved from where we dropped it till the entire water got colored. So now we call this process in which two or more particles mix with each other as diffusion. So intermixing of two or more particles is called diffusion. When two or more particles mix with each other, we call this process as diffusion. Then there was another definition of diffusion, that the movement of particles from a region of higher concentration to a region of lower concentration. Means the place where the amount of water was the amount of substance which we are mixing was more, it gets to a place where the amount was less. For example, if we talk about honey and ink in the water, the ink is light in weight, so if we drop ink particles, they are maximum at the top, so they move to the bottom. Whereas if we drop the particles of honey, they collect at the bottom. When they collect at the bottom, they tend to move upwards because the region of higher concentration was at the bottom now. Whereas in case of ink, it was at the top. So I was telling about this only when you people join, that it depends on density. If there are lighter particles, then the rate of diffusion, means the amount of diffusion, will be more if the particles are light in weight. Whereas if they are heavier in weight, then the amount of diffusion will be less. Similarly, if we take hot milk and cold milk, we try to add sugar in both of them. in which it would be easier to mix the sugar, in the hot milk or in the cold milk? Can you tell?
Ma'am, in the hot water.
Yes, in the hot milk. Vignesh and Pranav, are you listening, children?
Yes, ma'am.
Okay. So whenever there is more temperature, the diffusion is more and the particles tend to mix with each other even more when the temperature is more. And last property we discussed was that the particles of matter attract each other. We are able to swim in the swimming pool. Why? Because the swimming pool has the water in the swimming pool has spaces between them. It lets us swim into it, and also they tend to attract each other. Similarly, I was explaining about the iron nail and chalk. If we take an iron nail, we take a chalk, we try to hammer both of them, the chalk particles breaks down very easily. Why so? Because the particles of chalk were not attracted to each other as much as the particles of iron. Clear, everyone?
Yes, ma'am.
Yes, children?
Yes, ma'am.
Children,
Yes, ma'am.
you revise till here. I'll upload whatever I have taught till now. Fine. And later, I'll make this entire PDF and upload on the app. You can revise from here. In case you have a doubt, you can connect with me. And in the next class, we will continue. Need not worry about it. We are going to revise the other things. Clear? And also, I'll share the link so that you all can see the videos of whatever activities we have discussed in the class. Fine?
Yes, ma'am.
Okay, have a great day, everyone. Thank you all for joining. Do revise, and in case of any doubt, you can connect to me. Thank you, everyone. Bye,
Thank you.
children.
Bye, ma'am. Thank you, ma'am.
Bye, ma'am.
Bye,
Thank you.
Vikas. Bye, children.